Hello everybody, welcome back to my channel. So today I've decided to just go over another A-level maths topic. It's differential equations. The title, the topic name may trip you over. You may think we're differentiating because differential, but in fact we're actually using integration today. So basically, if you don't know how to use chain rule, product rule, quotient rule, every single integration rule, I recommend you thoroughly go through those rules first before trying differential equations, because if you get to like something with a trigonometric identity and then you also have like something to do with you may get a bit confused on what to do. So get that all down, like get the foundations down, and then come back to differential equations when you're ready. So we're just going to be going through really simple basic differential equations today. So let's just start off the first one. So before we start, there's a difference between the general solution and the particular solution, right? So with the particular solution, you'll have a specific or certain value for the arbitrary constant, but with the general solution you'll have just the arbitrary constant. If you don't know what arbitrary constant is, it basically is just the plus c at the end of every single integration thing you do, right? So here the question is asking us for the general solution, so it's just the arbitrary constant. So if you don't really, or if you've never done differential equations before, it's basically putting every single x value on one side and then every single y type of value on the other side, and then you integrate it all, right? So we'll do that here. So you can see there's a dy by dx. I was told at A level the dy by dx shouldn't be or isn't identified as as a fraction, but for some reason at A level it's classed as a fraction. I don't have the deep enough knowledge into maths to know why, but it is what it is, so we'll just stick with that for now. So you see this dx here, right? We can just times it on both sides, so we'll just times dx here or times dx here, right? The dx and dx will cancel out, and then we're left with dy equals x plus 2 cubed dx, right? So this is kind of looking like more like a integral equation, right? So we have dy equals da da da. So obviously in order to integrate, we just need to put integration symbol on both sides, and we don't have any limits, so it'll just be a non-limit integration. So you just do integral of dy, obviously that's just y, right? Then you have equals integral of x plus 2 all cubed with respect to x, right? So we can just integrate the left side first because that's the easiest. So let's do y, and then obviously you integrate as per usual. This is exactly the same as anything. So like integral of x plus 2 cubed dx, how would you integrate that, right? It's the same thing here, just with the y on the left side. So here it would be 1 over 4, and then everything stays the same in the inside bracket because this is just reverse chain rule, power 4. And then obviously you got to remember your arbitrary constant, which is just plus c, right? Because there are no limits, and right? So that's the first question complete, because it asks for the general solution and not for the particular solution, right? If there was a particular solution, it would say, let y equal 3 and x equals 7 and find the arbitrary constant and then write out a particular solution, right? But it doesn't. So we'll crack onto the second question, which we'll tackle with a particular solution. Okay, so I've created or found actually a new question. So it says find particular solution for this following function. So first things first, is to put all the x values onto one side and all the u values in this context, because it's du, onto one side. So the easiest thing we can do here is divide both sides by the x squared minus 3. So we're just left with du dx, if I can actually write du, dx equals 4x all over x squared minus 3, right? So got something. a little bit nicer here. It looks a bit more familiar. And then what we can do here is multiply both sides by dx as like we did previously. And we get 4x over x squared minus 3 dx. And then obviously we integrate both sides. So we do the integral of du, which is just u, and then the integral of 4x over x squared, subtract 3 with respect to x. So then we get u is equal to, what can we do here? We could factor out a 2. That could work. So we'll have 2 outside, the integral of 2x over x squared minus 3. Obviously, factoring out doesn't affect the denominator because realistically it would be 2 over 1, the integral multiplied, and then obviously, right, thinking of your fraction rules. And then with respect to x, and when we integrate this, we get u equals 2 because of the outside bit. And then ln, or natural logarithm, the modulus function of x squared minus 3. And then obviously remembering our arbitrary constant. Just realized I've forgotten to write the values that the question gives us. So it says in the question that when u is equal to 5, so when u equals 5 and when x equals 2, right? So what we can do here to find this arbitrary constant is sub in the values. So we know u equals 5, so we'll do 5 equals 2 natural logarithm of the absolute value of x squared, which we know is 2 squared minus 3 plus c. And then what we can do here is grab our calculator. Sorry, I just had to grab my calculator there. Okay, so we have 5 equals 2, and then modulus, so we have what? 4 minus 3 plus c, and 4 minus 3 is 1, so ln of 1 is 0, so that doesn't even matter. So this entire bit cancels out because 2 times 0 is just 0. So therefore, our arbitrary constant equals to 5, right? We're not done here though yet because we have to write the particular solution. This is just the arbitrary constant. We haven't actually written down the actual answer because the actual answer is a particular solution, and particular solution is not arbitrary constant, right? So the answer would be u equals 2 ln absolute value of x squared subtract 3, and then plus your arbitrary constant that we just found, which is 5. So it will be plus 5, and that'll be your final answer for the particular solution. So just to remind you guys, the particular solution, right, doesn't have plus c at the end. If you see a plus c and the answer and the question is asking you to find a particular solution, then you're missing out the final step because you need to find the c, the actual value of c. It can't just be a general constant, right? But if it's asking for the general solution, you can just stop at that point there because it's only asking for the general solution, because depending on the value of your u and your x, it can change the arbitrary constant. So yeah, just a tip there, right? So we'll move on to the third and final question, which will be a little bit harder, and I'll write that down and be back in a second. Okay, so I'm back with the third and final question of today, and we have 2 parts. So this is more of a exam styled question. This is typically what you may see as an exam question. This is on the easier side, but you know, get the concept round and stuff like that. So yeah, we have the A part of the third question, which is just partial fractions. This is not differential equations, it's just isolating partial fractions to topic. And then it incorporates partial fractions with differential equations. So yeah, you'll see. If you can't see already, it'll be chained together, right? So let's just do part A first. So we'll just simply factorize the denominator, so we can then actually make it to partial fractions. So it'll be x minus 8 all over x minus 3 and x plus 2. Just to make sure that's correct, we can expand out the bracket, so we're on the side here, so it'll be x squared minus 3x plus 2x minus 6. That does give us indeed x squared minus x minus 6, so that's correct. And then what we can do is do x minus 8 equals a over x minus 3 plus b over x plus 2, right? This is just simple partial fractions. If you don't know how to do partial fractions, I will link somewhere. I'm like 99% sure I've done a video on it, but it's been quite a while, so if I haven't, I will link another video to partial fractions if you don't know how to do it. But I'm pretty sure if you're at the stage of learning differential equations, you would have done partial fractions, because it's the very first chapter of the second year pure maths A-level course, right, for EdXL specifically. But anyways, yeah, okay, so then we can do x minus 8 equals a home bracket x plus 2 plus b in bracket x minus 3 close brackets. Okay, so now what we can do is set x equal to 3 or something. So let x equals 3 and we get minus 5 equals 5a, and therefore a we know now is negative 1. And then we can do let x equals to negative 2. Negative 2, negative 8 is negative 10, which equals negative 5b, if I can write b. So therefore we know that b is equal to positive 2, right? And then obviously we can just write it out again, and our answer is equal to negative 1 over x minus 3 plus 2 all over x plus 2. And there is our answer for part A, right? So that was nice and simple. Got that down. You can also rewrite it as 2 over x plus 2 subtract 1 over x minus 3 if you want to, write it in a nice way. I mean, I'll do it like that as well, because it just looks a little bit nicer. It's nicer to work with a positive number first and then work with a negative number after, right? So we could also write it there. It's exactly the same thing, but just flips around. And in part B asks us, given that x squared minus x minus 6 dy by dx equals x minus 8, and that y equals natural logarithm of 9 when x equals 1, show when x equals 2 that y equals the natural logarithm of 32. So in order to do this, we'll have to, again, do this process that we do for differential equations, which is put all of the x's on one side and put all the y's on the other side. And with all three of these questions, if you haven't noticed yet, we've only had the dy or the du, where so one variable is just the dy or the d variable, right? And then the rest of it's just been dx and x and whatever, right? But with harder differential equations, you'll have where both variables will have different factors within them. So it wouldn't just be dy, there'd be like 2y squared minus 3y minus 1, and then you have to integrate both sides, right? But here we're just sticking with dy and just all the x variables, right? Just a heads up before you freak out on any other differential equations, but it'll be the same concept. I'll cover that in another video, but for now it's just this. So anyways, I'm going off on a tangent. So what we can do is divide both sides by the x squared minus x minus 6, and this is where part A comes in handy if you get it correct. So what we can do is do dy by dx equals x minus 8 over x squared minus x minus 6. And of course we want all the x's on the same side, so we'll multiply both sides by dx. So this becomes dy, which equals x minus 8 over x squared minus x minus 6, all with respect to x, right? And then of course, because we're doing differential equations, we need to integrate. So it'll be the integral of dy, and just for time purposes, this is the partial fractions. That is the answer. They're the same thing. So we'll rewrite this part as this part, right? So it'd be the integral of 2 all over x plus 2, subtract 1 all over x minus 3, and all of this is with respect to x. Okay, so of course now we can integrate the left side, and that's just y, and then we have our two parts which we can just integrate one by one, and obviously which is using the ln rule. So it'll be equals to 2 natural logarithm modulus of x plus 2. I think that's correct. Yes, it is. Then subtract ln of modulus of x minus 3. There we go. And obviously we got to remember, sorry for the slanted writing, the plus c are arbitrary constant, right? And of course we know that x is 1 and y is ln 9. So what we can do is find c before we prove that when x equals 2, y equals ln 32, right? So what we can do here is sub in, highlight it yellow and write in yellow. Sub in this value for y and sub in this value for x, right? So we get ln 9 equals 2 ln absolute value of 1 plus 2 minus ln modulus 1 minus 3 plus c. So what we have here is ln 9 equals, so the modulus of 1 plus 2 is just 3, so it'll be ln 3 squared, and then minus, so 1 minus 3 is negative 2, but we need the absolute value, so it'll be minus ln 2 plus c. And using our natural logarithm rules, we can get that ln 9 equals ln 9, minus ln 2 plus c, and obviously ln 9 minus ln 9 will just be 0 because you're subtracting both sides, right? And you can cancel these out, and then we're just left with negative ln 2 plus c, so therefore c equals ln 2, right? That hopefully that makes sense. We were just using logarithm rules to move the 2 here to make it a squared, and then we add the inside of the modulus here to get ln 3, and then that obviously becomes ln 3 squared, and then 3 squared is 9. But obviously, because there's another ln 9, we can subtract both sides, and that will give us 0. And then we're just left with negative ln 2 plus c, and then we can rearrange to get just c by itself, and that's ln 2, right? So our specific equation here would then be y equals 2 ln modulus of x plus 2 minus ln modulus of x minus 3, remembering our arbitrary constant, which is plus ln 2, right? So we have this equation here now. I will color that in blue, and then we can then work out or show the proof, right? So we have show when x equals 2, y equals ln 32. So x equals 2 and y equals ln 32. This is what we need to show. So what we can do here is obviously sub in the values, but don't sub in y, because that's what we're trying to find, right? So it would just be y, because that's what we're trying to find, equals 2 ln modulus of 2 plus 2, which is just 4, minus ln modulus of 2 minus 3, which is just negative 1, but modulus of, or the absolute value of negative 1 is 1, and then ln1 equals 0, right, as we found earlier, so we can cancel that out later on, and then we have plus ln2, which is our arbitrary constant. So we have y equals, we can simplify all this, so it'll be ln of 4 squared minus ln of 1 plus ln2. So we can cancel this out because this is just 0. And then what we're left with is y equals ln of 16 plus ln of 2. Now, you can't plus this because they're both ln. So what you're going to want to do is use your natural logarithm rules, your logarithm rules, whatever you want to call it. But it states that when you subtract two natural logarithms, you divide them. And if you add them together, then you get, or when you add them together, you have to multiply them, right? So it'll be y equals ln of 16 times 2. So y equals ln of 32, which is our proof complete, right? It shows this statement above from the question. So hopefully, I did rush the end a little bit there just for timekeeping purposes, but hopefully that all makes sense. If you do have any further questions about this, let me know in the comments below. But yeah, this is the most simplest differential equations you'll probably see in your exam. So yeah, hopefully this helps, and I'll see you all later.